Now we have another Python example. We will have a live spectrogram of a microphone signal, and we'll talk about aliasing and downsampling, upsampling, like the previous basic blocks of multirate signal processing we talked about last notebook. At this point, I am importing all the libraries. We're going to use PyAudio again. We're going to use Matplotlib. We're going to use Jupyter widgets to have a graphical user interface. We're going to use threading. These are the libraries. Here is the configuration of the parameters we're going to use. So we're defining sampling rate, defining the factor of downsampling and upsampling, number of FFT, overlap. And now we're creating a low-pass filter. We are using SciPy to have this filter. Notice that we have a sampling rate of 32 kilohertz and our downsampling and upsampling factor is 8. So we remember that we discussed that we need to have a filter 1/8 of the Nyquist frequency of the higher sampling rate. So sampling rate is 32 kilohertz. The Nyquist frequency would be 16 kilohertz. 1/8 of 16 is 2. So we need to have it smaller than 2. I'm having here 1.9 kilohertz. And here we are defining our low-pass filter. And we can see, just plotting frequency response of our low-pass filter, we have phase and we have our cutoff frequency at around 1.9 kilohertz. And this is a function that will plot a spectrogram that will get the audio stream, convert it to samples, plot the spectrogram. So this is the function I'm calling run spectrogram. It will be controlled by a button. So we are reading from the stream, getting the samples. If the low-pass filter before downsampling is on, it will filter the signal. This part here is a combination of downsampling and upsampling together. So when we downsampling, we are removing number of samples, and we are upsampling, we're inserting zeros in between samples. So when we combine these two, it's like if we're making some a number of samples to 0. So it will be what we're doing in this part here. This is the low-pass filter after upsampling. So if the filters will be on, it will filter the signal. This part will play back the audio from the microphone, and this will update our spectrogram. At this part, we are creating our graphical user interface. We are having some buttons to control the start and stop, and to use downsampling and upsampling is on or is off, and the low-pass filters. Here we are creating a thread, so we want to run this function inside a separate thread so we can have access to the control buttons. At this point is the usual configuration of PyAudio. We create a PyAudio instance, we create a stream. Here it will initialize our plot and create our graphical user interface. So we will display the buttons. It will display a starting plot. This will handle when we close the plot, what should happen. When we run this cell, we have here our controls, and this will be our live spectrogram. When we start, so we can see our spectrogram. Now we are using the guitar as a signal input, and we are playing a note. When we activate downsampling and upsampling, we can hear and see aliasing. So there are no filters at the moment, but when we activate the filters, we can reconstruct up to 2 kilohertz. If we remove the filters, we can hear and see aliasing again.